Hey, fellow microbe enthusiasts, and welcome to Bugs and Beyond. Are you ready for a deep dive
I am.
into the world of phosphomycin? It's a naturally occurring antibiotic with a story
It is.
way more exciting than you might think.
Definitely.
Now, before we get started, I always like to start with a quick moment of gratitude.
Oh, absolutely.
Just take a deep breath and think about something that brings you joy.
Yeah.
Maybe it's a warm cup of coffee, or a furry friend, or even just the fact
What a good one.
that we're about to unravel the mysteries of phosphomycin together.
I like that one.
All right, so now phosphomycin,
A positive mindset really unlocks learning potential.
it really does.
So that's great.
So phosphomycin is an antibiotic with an interesting history.
It is.
It was actually discovered back in 1969
Yes.
from a type of bacteria called Streptomyces.
Uh-huh.
Now Streptomyces, it's actually a friendly microbe with,
You can think of it that way.
a hidden talent for fighting off
That's right.
its less friendly counterparts.
Yeah.
Okay, so that makes sense. But I'm curious,
Yeah.
if it was discovered back in the 60s,
Yeah.
why haven't I heard more about it?
That is a good question. And it's interesting because a lot of the antibiotics that we do hear about are much older.
They are?
But this is where the story takes a little bit of a turn.
Okay.
So even though phosphomycin was discovered back in '69, it wasn't immediately embraced as like a wonder drug.
Oh, really?
Yeah, researchers actually initially kind of shelved it
Why?
because it had inconsistent activity in the lab.
Oh.
So they thought, well, this isn't very good. We're going to put it aside.
It wasn't reliable.
Yeah, and it wasn't until later that they discovered a crucial piece of the puzzle,
Good.
and that is that phosphomycin actually needs a partner in crime.
Oh.
It needs a molecule called glucose 6-phosphate
Okay.
to really flex its antimicrobial muscles.
So it's like a superhero waiting for its trusty sidekick
Yes.
to activate his powers.
Exactly.
That's so cool. So I'm guessing once scientists figured that out,
Right.
they were able to really understand how it works.
Yeah. So they finally had the right conditions
Uh-huh.
to study it and to figure out what it was doing.
Okay.
And it turns out
Yeah.
that phosphomycin acts like a sneaky saboteur.
Ooh.
It infiltrates bacteria
Okay.
and then disrupts their ability to build strong cell walls.
And the cell walls are like the bacteria's armor.
That's a good way to put it.
Right. Protecting them from the outside
Yeah,
world.
exactly.
Okay.
Yeah.
So far, so good. But how does it get inside the bacteria to wreak havoc?
It's not just barging in there.
Right.
It's a little bit more strategic.
Yeah.
It actually uses very specific transport systems.
Oh.
So you can imagine these like tiny gateways into the bacterial cell.
Mm-hmm.
And these systems are called GLPT and SDMLPT.
All right.
And they're essential for the bacteria's normal function,
Mm-hmm.
but they unknowingly become phosphomycin's secret passageway.
So it's like it's a secret agent using a fake ID
I like it.
to slip past security
That's a great analogy.
and gain access to the bacteria's inner sanctum.
Yes.
All right, but let's get down to the nitty-gritty.
Okay.
Once phosphomycin is inside, how does it actually disarm the bacteria's defenses?
Right. So it actually goes straight for the heart of the operation. It targets an enzyme called MurA.
MurA.
And MurA is responsible for building those sturdy cell walls.
Okay.
So you can think of MurA like a construction crew that's diligently laying brick by brick to create a fortress for the bacteria. But phosphomycin acts like a wrench thrown into that machinery.
Oh.
It halts the construction process.
Okay, so no cell walls,
Yeah.
no protection.
Right.
The bacteria are just left exposed.
Exposed and vulnerable.
And vulnerable.
Uh-huh.
And I'm guessing that's when our immune system can swoop in and finish the job.
Precisely.
Okay.
Without those protective walls. The bacteria become easy targets for our immune system's defenses. And this makes phosphomycin what we call bactericidal, which means that it actually kills the bacteria.
Instead of just inhibiting their growth.
Exactly. It doesn't just slow them down.
Wow.
It actually destroys them.
Okay, so we've got this sneaky antibiotic infiltrating bacteria, shutting down their construction projects.
That's right.
And leaving them defenseless against our immune system.
Yes.
It's like a microscopic action movie.
It is.
But before we move on, let's do a little knowledge check.
Okay.
Pop quiz time.
All right.
What is the enzyme that phosphomycin targets to disrupt cell wall synthesis?
Okay.
So your options are A, DNA polymerase,
Okay.
B, RNA polymerase,
Right.
C, MurO,
Right.
or D, ATP synthase. Take your time, folks.
No pressure.
No
pressure.
Think back to our construction crew analogy.
Yeah, think about that wrench.
Yeah, what was the name of that crucial enzyme?
All right, time's up.
The correct answer is...
C.
MurA.
So if you remember...
Good job, everyone.
MurA is like the construction crew boss.
Yes.
Responsible for building those bacterial walls.
Yes.
And phosphomycin throws a wrench in the works.
Exactly.
By inhibiting MurA's activity.
Okay.
Now, the other options that were presented...
Yep.
Those are all enzymes that are involved in other cellular processes.
Right.
But they're not the ones that are targeted by phosphomycin.
Excellent work, everyone.
Yes.
You were clearly paying attention.
Clearly.
Now let's get back to our phosphomycin adventure.
Okay.
We know it's great at taking down bacteria.
Yes.
But how does it get around in the body?
That's another good question.
Does it travel by jetpack?
Well, maybe not quite that exciting.
Okay.
But it does have a fascinating journey.
Okay.
And this is where we get into what is called pharmacokinetics.
Pharmacokinetics.
Which is basically how a drug moves through the body.
Okay.
So when taken orally, phosphomycin is absorbed fairly well. And it has a relatively short half-life.
Short half-life.
Meaning it doesn't stick around in the body very long.
So it's a quick in and out mission.
Yeah, you could think of it that way.
Get in, take down the bacteria, and then get out.
Exactly.
But here's something that's been bugging me.
Okay.
I know that in the U.S., phosphomycin is only available orally as phosphomycin tromethamine.
Yeah.
What's the deal with that?
So that's a great question. Yeah. And the tromethamine part isn't just for show.
Okay.
It actually plays a really important role in how phosphomycin works in the body.
Really?
Yeah. So you see tromethamine.
Okay.
It helps phosphomycin dissolve more easily and be absorbed into the bloodstream.
So it's like giving phosphomycin a special suit.
Yes.
That allows it to move more efficiently through the body.
Exactly.
Okay.
Then got it.
So tromethamine is like phosphomycins.
We could think of it as like a sidekick.
A little helper.
Yeah, for better absorption.
All right, that makes a lot of sense.
Good.
I'm starting to think that phosphomycin's a pretty well-equipped secret agent.
It is.
But where does it go once it's in the bloodstream?
Okay, so it's not just roaming around aimlessly.
Right.
It has a specific target in mind.
Okay.
And that is the urinary tract.
Okay.
So the majority of it is filtered out by the kidneys and ends up in the urine.
Okay.
Where it can reach very high concentrations.
Okay, and that's precisely why it's so effective for treating UTIs.
That is exactly right.
So it takes a direct flight to the urinary tract.
Yes.
Ready to ambush those UTI-causing bacteria.
Exactly.
In their hideout.
That's a great way to put it.
I love these analogies.
Me too.
But which bacteria are on its hit list?
Okay, so phosphomycin is particularly known for its activity against some of the most common culprits behind UTIs.
Okay.
So things like E. coli, Klebsiella, and Enterobacter.
Those are the usual suspects.
The usual suspects in a bacterial lineup.
They're responsible for a lot of misery.
They are.
But I've heard that phosphomycin can also take on some less common bacteria.
That's right.
Is that true?
Absolutely.
Okay.
So while it's best known for its role in tackling UTIs, phosphomycin also shows activity against some surprising targets, like Salmonella, Shigella, and even Listeria.
Hold on, Listeria.
Yeah.
Isn't that the one we need to be extra cautious about with like deli meats?
That's the one.
And soft cheeses.
You got it.
Really?
Yep.
Okay.
So it is a multi-talented secret agent.
That's pretty impressive.
Yeah, it can handle a variety of missions.
So wow, that's interesting.
Yeah.
It can target Listeria, but it's not always the first choice for
We
treating
know that.
infections caused by Listeria.
And that's because
Yeah.
doctors consider a variety of factors.
Of course.
When choosing the best treatment for each specific situation.
Right, because every infection is unique.
Yep.
And what works best in one case might not be the best approach in another.
Exactly.
It's all about personalized medicine.
It is.
But this just goes to show how versatile phosphomycin can be.
Yeah, it does.
It's like a secret agent.
Yeah.
With a whole arsenal of gadgets and techniques at its disposal.
I like that analogy.
Right.
Yeah.
But no matter how skilled or well-equipped an agent is, there's always a chance that the enemy will develop countermeasures.
That's true.
And in the world of antibiotics,
that
means bacterial resistance.
Bacterial resistance.
So how are those crafty bacteria fighting back against phosphomycin?
Okay, so bacteria have a few tricks up their sleeve.
Okay. What kind of counterintelligence strategies are they deploying?
Yeah, so they can develop resistance to phosphomycin in several ways. But let's just focus on the three most common mechanisms.
Okay.
So imagine it as a bacterial defense strategy.
Okay.
In 3 acts.
Ooh, a 3-act play.
Yes.
I'm intrigued.
Tell me more. All right, so Act 1 is all about stealth and sabotage.
Okay.
So bacteria can alter the shape of their MurA enzyme.
The one that phosphomycin targets.
Yes.
So it's no longer a perfect fit.
Exactly.
So it's like changing the locks on a door.
Yes.
So the key phosphomycin can't get in.
You got it.
Clever little buggers.
They are crafty.
We're changing the blueprints.
Yes.
So our weapon can't hit its mark.
Right.
What about Act 2?
All right, so Act 2...
What kind of drama unfolds there?
It's all about overwhelming force.
Okay.
So bacteria can flood their cells with extra copies of the MurA enzyme.
Okay.
That way, even if phosphomycin manages to block some of them, there are still enough functioning ones left to keep building those cell walls.
So it's like they're deploying a decoy army to distract our forces while they continue their construction project in secret.
Exactly. It's very clever.
Okay, so Act 1 is about stealth.
Yes.
Act 2 is about brute force.
That's right.
What's the grand finale?
All right, Act 3.
What is Act 3?
It's all about closing the borders.
Okay.
So bacteria can mutate those transport systems.
The GLPT and FTT.
Yes, you remember those?
Gateways, yeah.
The gateways, right? So they can mutate those, making it much harder for phosphomycin to enter the cells.
So they're essentially building a wall to keep phosphomycin out.
Exactly.
It's like a microscopic border patrol, keeping our secret agent stranded outside.
Yeah.
This whole bacterial resistance thing is pretty intense.
It is. It's a problem.
Are there any specific names or labels for these resistance mechanisms?
Yeah, so scientists have identified specific enzymes that play a role in these resistance mechanisms. For example, Pseudomonas and Acinetobacter. These are 2 types of bacteria, often found in hospitals. They use an enzyme called FOSA to break down phosphomycin, rendering it ineffective.
Wow, so it's like a whole network of bacterial spies and saboteurs.
It is.
Each with their own code names.
Yeah.
And special skills. It really makes you appreciate the ongoing battle.
It does.
Between antibiotics and these microscopic adversaries.
Yeah.
Now, this raises an important question.
Okay.
How do we stay ahead of the bacteria in this arms race of antibiotic development and resistance?
Yeah, that's a crucial question.
It's like we're always trying to outsmart them.
We are.
But they're constantly adapting.
That's right. It's a challenge.
That is a very crucial question.
Yeah, and one that researchers are constantly grappling with.
Right.
And we'll definitely delve into some potential solutions and strategies later on in our deep dive. But first, let's shift gears a little bit and explore another important aspect of phosphomycin.
Right.
And that is its potential side effects. Because as with any medication, it's essential to understand both the benefits and the risks.
Absolutely. We need to be aware of the potential downsides.
Yes.
Not just the superhero feats.
Right.
So spill the tea. What are the possible side effects of phosphomycin?
Okay, so the good news is phosphomycin is generally well tolerated and serious side effects are rare.
All right. That's reassuring to hear.
Yeah. So think of it as a secret agent with excellent field skills, minimal collateral damage. So the most common side effects are gastrointestinal issues. Like diarrhea, nausea. Some people might experience vaginitis. But it's important to remember that these side effects are generally mild. And they tend to occur in a relatively small percentage of people.
So not a free pass.
Right.
But the risks are generally manageable.
Exactly.
Are there any serious allergic reactions to watch out for?
That's a good question.
Yeah.
And actually, one of the great things about phosphomycin is that serious allergic reactions, what we call hypersensitivity reactions,
they're incredibly rare.
Really?
Which makes it a safer option for people who might be allergic to other types of antibiotics.
That's definitely a point in its favor.
It is.
What about interactions with other medications?
So there is one interaction to be aware of.
Right.
Phosphomycin's absorption can be reduced when taken with medications that speed up digestion. Or what we call gut motility.
Got it. Like what?
Metoclopramide is one example.
Metoclopramide, okay.
Yeah, so it's essential to tell your doctor about all the medications you're taking.
Right, because sometimes even seemingly harmless medications
That's right.
can interact with each other in unexpected ways.
Exactly.
It's always better to err on the side of caution.
Yes.
And have open communication with your healthcare provider.
Absolutely.
Now let's get to the heart of the matter.
Okay.
When does phosphomycin really shine in clinical practice?
All right, so phosphomycin's primary claim to fame
is its effectiveness in treating uncomplicated acute cystitis?
Uncomplicated acute cystitis.
Which is a fancy way of saying straightforward urinary tract infections.
Okay.
So think of it as a UTI specialist.
Okay.
A master at tackling those pesky bladder infections.
Okay, but why is it such a good choice for UTIs?
Okay, so that's a great question.
Is it just because it reaches high concentrations in the urine?
So that's a big part of it, but there's more to it.
Okay.
So remember how we talked about phosphomycin's effectiveness against those common UTI-causing bacteria?
Yes, like E. coli.
Like E. coli, exactly. So that's another reason why it's such a potent weapon.
So it's a double whammy.
Yes.
High concentration in the urine, and targeted action against those common UTI culprits.
Exactly.
That's a winning combination.
It is.
Are there any other situations where phosphomycin might be used?
Okay, so while uncomplicated UTIs are its main gig, phosphomycin can also be considered for more complex UTI cases.
Okay.
And sometimes it's even used as a preventative measure.
Oh, wow.
For people who experience recurrent UTIs.
So it's got a few tricks up its sleeve beyond just simple UTIs.
Yeah, it's a versatile agent.
Okay.
Capable of adapting to different scenarios.
With all this talk about phosphomycin being used for UTIs, I'm curious about the dosage.
Okay.
How much do you typically take and how often?
All right, so that's a crucial question.
It is.
Because the dosage is very important for phosphomycin to work effectively.
Okay.
And for uncomplicated UTIs, it's typically given as a one-time high-dose treatment.
One-time high-dose treatment.
But to test your knowledge.
All right.
Let's have another pop quiz.
Round 2.
Ready for round 2.
Our listeners are phosphomycin experts in the making.
They are.
All right, hit me with the question.
Okay, so the question is, what is the typical recommended dosage of phosphomycin?
Let's go with uncomplicated cystitis.
All right.
So here are your options.
Okay.
A, 1 gram 3 times a day for 7 days.
Okay.
B, 500 milligrams twice a day for 5 days.
Right.
C, 3 grams single dose.
Okay.
Or D, 10 grams single dose.
All right, take a moment to think about it.
Remember, we're talking about uncomplicated UTIs.
Uncomplicated UTIs.
Uncomplicated UTIs.
And phosphomycin's typical dosing strategy for those infections.
All right, time's up.
What's the answer?
The answer is C. 3 grams.
3 grams.
As a single dose.
Single dose.
Remember, phosphomycin.
One and done.
One and done.
For uncomplicated UTIs.
All right, and to help you remember this crucial detail, here's a fun mnemonic.
Okay, let's hear it.
Phosphomycin UTI gone in 3.
I like it.
3 grams. One and done.
Catchy.
Catchy, right?
It is.
All right, but it's important to emphasize
yes.
that while mnemonics
yes.
can be helpful for remembering information, they shouldn't replace the guidance of your healthcare provider.
Right.
Always follow your doctor's instructions.
Yes.
And the directions on the medication label.
Very important.
Absolutely. Never rely solely on mnemonics.
Right.
For medical information, always consult with your doctor.
Yes.
For personalized guidance.
Absolutely.
All right, and on that note of expert advice, we are going to take a short break.
Okay.
But don't worry, we'll be back soon.
Sounds good.
To continue our phosphomycin adventure.
I can't wait.
So in the next part of our deep dive, we'll explore some of the exciting new research, potential future applications, and the ongoing efforts to combat bacterial resistance.
All right.
So stay tuned.
I will. Welcome back, microbe explorers.
All right, I am ready for more.
We've covered a lot of ground in our phosphomycin adventures so far.
We have.
But just when you thought we'd exhausted all the secrets of this intriguing antibiotic, we're about to take things to a whole new level.
I am all ears. What's next on our phosphomycin agenda?
Okay, well, one of the things that makes phosphomycin so fascinating is that researchers are constantly exploring new and innovative ways to use it.
Okay.
So think of it as an antibiotic with a bright future, constantly evolving and adapting to meet the challenges of a changing microbial world.
I'm always up for exploring new frontiers.
Good.
What kind of research are we talking about? Give me some examples.
Okay, so for starters, scientists are working on developing new formulations of phosphomycin that might improve its absorption or target specific areas of the body more effectively.
Okay, so like a supercharged version of phosphomycin.
Yeah.
Engineered for even greater precision and potency.
Right.
What kind of modifications are we talking about here?
So one promising area of research is using nanoparticles.
Nanoparticles, okay.
To deliver phosphomycin directly to infection sites. So these nanoparticles are like tiny delivery trucks carrying phosphomycin straight to the bacterial battlefield.
Wow, that's incredible.
Minimizing collateral damage and maximizing its effectiveness.
So instead of just sending phosphomycin on like a general patrol, we're giving it a GPS and a specific target.
You got it.
It's like a microscopic guided missile system for antibiotics.
That's a great analogy.
What other innovative strategies?
Okay, another fascinating avenue of research involves combining phosphomycin with other antibiotics.
Okay.
And the idea is that by teaming up phosphomycin with other antimicrobial agents, we might be able to enhance its effectiveness, overcome resistance mechanisms, or even broaden its spectrum of activity.
So it's like assembling a superhero team of antibiotics.
Exactly.
Each with its own unique strengths to take on those bacterial villains.
Yeah.
Are there any specific combinations that are showing promise?
So researchers are investigating a variety of combinations. And some early studies suggest that pairing phosphomycin with antibiotics like beta-lactams or aminoglycosides could be particularly potent. But it's not just about finding the right partners. It's also about determining the optimal dosage and timing for each combination.
Because even superheroes need to coordinate their efforts.
They do.
For maximum impact.
That's right.
It's about finding that perfect synergy between different antibiotics to create like a truly unstoppable force.
Yes.
But I'm curious, are there any potential uses for phosphomycin? Beyond UTIs that researchers are excited about?
Yeah, that's a great question.
Is its expertise limited to the urinary tract?
Or
can it branch out into other areas of infection control?
So while UTIs are its primary domain, phosphomycin is showing promise in a surprising variety of other infections.
Like what?
So scientists are investigating its potential against some of the most formidable foes in the bacterial world, including those that have developed resistance to multiple antibiotics.
Wow.
So we're talking about infections like pneumonia, bloodstream infections, and even bone and joint infections.
Wow, that's a pretty diverse lineup of infections.
It is.
It sounds like phosphomycin could become a valuable asset in our fight against some of the most challenging and life-threatening infectious diseases.
That's right.
But with all this talk about new applications and expanded potential, I can't help but think about the looming threat of antibiotic resistance.
Yes, it's always there.
How do we ensure that phosphomycin remains effective in the long run?
So that's $1 million question.
It is.
And it's one that requires a multifaceted approach.
Okay, I'm ready for a strategic briefing.
Right.
What are the key elements of this global plan?
So one crucial aspect is promoting responsible antibiotic use. And this means using antibiotics. Only when they're truly necessary. Avoiding overuse or misuse and ensuring that patients complete their full course of treatment as prescribed. Even if they start feeling better before finishing all the pills.
So it's about being mindful and strategic.
It is.
Not treating antibiotics like a quick fix for every sniffle.
That's right.
But respecting their power. And using them judiciously.
Yes.
It's like a public health campaign to educate people.
Exactly.
About the importance of responsible antibiotic use.
It is.
What else can we do?
Okay, so another critical piece of the puzzle is investing in research and development of new antibiotics. And this is because we need a constant influx of fresh recruits. New antimicrobial agents to bolster our arsenal and keep pace with the ever-evolving tactics of those bacterial adversaries.
So it's like a never-ending arms race. With scientists working tirelessly. To develop new weapons to combat those ever-adapting bacterial foes.
That's right.
But is it all about developing new drugs?
So it's not all about developing new drugs.
Okay.
Collaboration is also key.
Okay.
So we need to foster partnerships between researchers, clinicians, policymakers, and the pharmaceutical industry.
So it's like assembling a global task force.
It is.
A dream team of experts from different fields.
Exactly.
All united in the fight against antibiotic resistance.
Right.
Now, I'm excited to hear about some of these innovative approaches.
Yeah.
What's on the horizon?
So one area that's generating a lot of buzz is the development of rapid diagnostic tools.
Rapid diagnostic tools. Okay.
So imagine a device that could quickly and accurately identify the specific type of bacteria causing an infection.
Okay.
And even tell us which antibiotics it's susceptible to.
Wow.
So think of it as like a super-powered microscope that can pinpoint the exact bacterial culprit and give us a personalized treatment plan.
That would revolutionize how we approach infections.
It would change everything.
What other cutting-edge technologies are being explored?
Another exciting area is phage therapy.
Phage therapy.
Okay. So phages are viruses that have evolved to specifically target and kill bacteria.
Hold on, phages. Those are viruses, right?
Yes.
Are we talking about using viruses to fight bacteria?
We are.
Isn't that a bit counterintuitive?
It might sound strange at first.
Yeah.
But remember, nature is full of surprises.
True.
So these phagers have been battling bacteria for billions of years.
Wow.
And they've become incredibly efficient at it. And because phages are highly specific, they typically only target the harmful bacteria, leaving our beneficial microbes unharmed.
Wow, that's incredible.
It's like having a precision strike force that can eliminate the enemy without causing collateral damage.
It's like science fiction coming to life.
It is pretty amazing.
But with all these exciting advancements and potential solutions, I imagine there must be some challenges and obstacles along the way.
Right. It's not always easy.
Yeah.
Developing new antibiotics and combating resistance is a complex and challenging endeavor.
Yeah.
And one of the biggest hurdles is the sheer cost and time involved in bringing new drugs to market.
I can imagine.
It can take years of research and billions of dollars to develop and test a new antibiotic. And there's no guarantee of success.
So it's a risky and expensive undertaking.
It is.
But one that is absolutely essential.
Absolutely.
For our future health and well-being.
It is.
What other challenges do researchers face?
Okay, so another significant challenge is navigating the regulatory landscape.
Okay.
So getting a new antibiotic approved for use can be a long and complicated process, often involving multiple stages of testing and review. And even when a new drug is deemed safe and effective, it still needs to be made available to patients.
Yeah.
Which can be another hurdle altogether.
So it's like running a marathon.
Right.
But with a bunch of bureaucratic hurdles along the way.
Exactly.
It's a testament to the dedication and the persistence of these researchers that any new antibiotics make it to the finish line.
Yeah. They're amazing.
Are there any other obstacles that we need to be aware of?
So one often overlooked challenge is the lack of public awareness and understanding about antibiotic resistance.
Yeah.
Many people just don't realize the seriousness of this issue
or
the role they can play in addressing it.
It's like a silent epidemic unfolding beneath the surface.
Yeah.
And many people are unaware of the danger.
That's right.
So how do we raise awareness?
So we need to make it a public health priority. And we can use things like public service announcements, educational campaigns in schools and communities, and even social media to spread the word.
Okay.
We can also engage healthcare providers to have open and honest conversations with their patients about the appropriate use of antibiotics.
So it's about creating a culture of awareness.
It is.
And responsibility.
Yes.
Empowering everyone to make informed decisions.
That's right.
About their health and the use of antibiotics.
Yeah.
With all this talk about challenges and solutions, it's clear that this fight against antibiotic resistance is a complex and ongoing battle.
It is.
But despite the hurdles, there's also a sense of hope and optimism, isn't there?
Absolutely.
We're not powerless in the face of this threat.
No, we're not.
Okay, good.
So while the challenges are real, there's a growing global recognition of the urgency and importance of addressing antibiotic resistance. And scientists, clinicians, Policymakers and advocates are all working together.
That's encouraging.
To find solutions, and we're seeing some promising advancements.
That's great.
On multiple fronts.
That is incredibly encouraging to hear.
It is hopeful.
It's inspiring to see so many people dedicated to tackling this critical issue.
Right.
It gives me hope that we can find ways to overcome these challenges.
Yes.
And ensure that antibiotics remain effective for generations to come.
That's the goal.
But as we wrap up this part of our deep dive, I'm left with a lingering question.
Okay.
What does the future hold for phosphomycin?
Right.
We've seen its potential, its versatility,
it's amazing,
and its resilience. Where do we go from here?
So that is the question.
It is.
That keeps researchers and clinicians up at night.
Right.
And while we can't predict the future with certainty, the current trajectory suggests that phosphomycin is poised to play an even more prominent role in our fight against bacterial infections. So its unique mechanism of action, its favorable safety profile, and its adaptability make it an ideal candidate for further exploration and development.
That's exciting to think about all the possibilities.
It is.
And as we continue to learn more about phosphomycin, it's crucial to remember that we all have a part to play.
We do.
In preserving its effectiveness.
That's right.
So we need to be responsible stewards of this valuable antibiotic, advocating for policies that promote responsible use, and supporting research
That's right.
that leads to new and innovative treatment approaches.
Exactly.
And on that note of collaboration and hope, we're going to take a short break to recharge and gather our thoughts.
All right, sounds good.
But don't go anywhere.
Okay.
We'll be back soon for the final chapter
I'm ready.
of our phosphomycin deep dive, where we'll synthesize all the key takeaways, explore some final thoughts,
Sounds good.
and leave you with some food for thought
All right.
to ponder as you continue your exploration of this fascinating world of microbes and medicine.
Okay.
So stay tuned.
I will.
Welcome back, microbe enthusiasts.
I'm ready for the final chapter.
It feels like we've journeyed through the entire bacterial world
It does.
and back exploring the ins and outs of phosphomycin, this remarkable antibiotic, with a story as captivating as its mechanism of action.
I agree.
Now, as we approach the final destination of our deep dive, it's time to reflect on all that we've learned.
Okay.
And distill the most important nuggets of knowledge about this multifaceted antibiotic.
Let's do it.
So think of it as creating a mental cheat sheet. Highlighting all the key points about phosphomycin's strengths, its quirks, and its potential for shaping the future of infectious disease treatment. So let's open our mental notebooks and recap the highlights of our phosphomycin adventure.
I'm ready.
So first and foremost, we need to remember that phosphomycin is not your average run-of-the-mill antibiotic.
Right.
It has a unique history.
It does.
A story filled with unexpected twists and turns.
That's right.
So discovered back in 1969, it was initially overlooked due to inconsistent activity in those early lab tests.
Yeah, it didn't always perform well.
But thankfully, researchers eventually realized that phosphomycin just needed a little help from its friend.
That's right.
Glucose 6-phosphate to truly shine.
Exactly. It needed the right conditions to show its true potential.
So it's a classic tale of scientific persistence.
It is.
It's a reminder that sometimes the most groundbreaking discoveries require a second look,
Absolutely.
a fresh perspective, and a willingness to challenge those initial assumptions.
Yes.
So once researchers unlocked that secret to phosphomycin's power, they were able to delve into its ingenious mechanism of action.
Yes.
Its ability to infiltrate bacteria like a stealthy saboteur.
That's right.
And disrupt their ability to build those protective cell walls.
That's right.
And we learned that phosphomycin targets an enzyme called MurA.
MurA.
Which is essential for the construction of those bacterial fortresses.
That's a good way to put it.
So by inhibiting MurA,
yes,
phosphomycin essentially sabotages the entire construction project,
exactly,
leaving those bacteria vulnerable and exposed.
That's right.
And what's even more fascinating is that phosphomycin has a specific affinity for the urinary tract. The majority of the drug ends up concentrated
That's right.
in the urine.
That's right.
Making it a formidable weapon.
It is.
Against those pesky urinary tract infections or UTIs.
Right.
And we even came up with a catchy mnemonic.
We did.
To remember the typical dosage for uncomplicated cystitis. Phosphomycin UTI gone in 3.
3 grams, one and done.
3 grams, one and done.
That's right.
But we also emphasize the importance of consulting with your healthcare provider.
Absolutely.
For personalized guidance.
Always a good idea.
Okay, so we've established that phosphomycin is a unique and effective antibiotic, particularly for UTIs.
That's right.
But as with any powerful weapon, there's always the risk of the enemy developing countermeasures.
That's right.
And in the world of antibiotics, that means bacterial resistance.
Bacterial resistance.
And we explored the various ways that bacteria can evolve to evade phosphomycin's attacks, including altering their target enzymes, producing extra copies of those enzymes, and even mutating their transport systems to block phosphomycin's entry.
Right. They're very clever.
It's a constant game of cat and mouse.
It is.
A microscopic arms race between our best defenses and the ever-adaptable strategies of those bacterial adversaries.
That's right. But it's not a hopeless battle.
No.
We discussed a range of strategies for combating antibiotic resistance, from promoting responsible antibiotic use to investing in research and development.
That's right.
Of new antibiotics and innovative treatment approaches. We even explored the potential of phage therapy.
Phage therapy.
Which harnesses the power of viruses to target and kill bacteria.
Exactly.
Now, it's a fascinating field.
It is.
Full of possibilities.
A lot of potential there.
And phage therapy could revolutionize how we treat bacterial infections, offering a more targeted and personalized approach that minimizes the collateral damage to our beneficial microbes.
That's right.
So it's incredible to think about all the groundbreaking research and innovation that's happening in the world of microbiology.
An exciting time.
And infectious disease treatment. And it's a constant reminder
that even in the face of daunting challenges, like antibiotic resistance, there's always hope.
There is.
There's always a reason to believe that we can find solutions and protect human health for generations to come.
Absolutely.
So I completely agree. It is an exciting time to be involved in this field.
It is.
And I'm optimistic that we can develop new strategies and technologies to stay one step ahead of those ever-evolving bacteria.
That's right.
And as we wrap up our phosphomycin journey, I think it's important to remember that we all have a role to play.
We do.
In this fight.
That's right.
Whether it's being mindful of our own antibiotic use, supporting research efforts, or simply spreading awareness about the importance of responsible antibiotic stewardship.
Very important.
Each one of us can make a difference.
We can.
So it's a collective effort.
It is.
A global responsibility to protect these precious medications.
Yes.
And ensure their effectiveness for future generations.
That's right.
And on that note of collective action and hope for the future, we bid you farewell, fellow microbe enthusiasts.
Farewell.
We hope you enjoyed this deep dive into the world of phosphomycin.
I did.
Now remember to like, subscribe, and share this episode with anyone.
That's right.
Who might be interested in learning more about antibiotics, bacterial resistance, and the ongoing quest to protect human health.
That's right.
So until next time.
Cook.
Keep exploring.
Yes.
Keep learning. And keep those curiosity fires burning.
I will. And may your journey of knowledge and discovery be filled with wonder and enlightenment.